In this video, we will solve a question on how to find out the units of capital and labor that maximizes the output given the production function and the cost constraint here. Okay, so the question is given the production function is Q is equal to 12K square times L square subject to the constraint that is 40 times K plus 5 times L is equal to 800. So 40 denotes the price of capital, 5 denotes the price of labor, and total cost that is to be incurred is equal to 800. We have to find out the amount of capital and labor that maximizes the output. Options are being given. We need to find out the correct option here. Okay, so since the question is about the maximization, so our endeavor will be to maximize the output, that is Q is equal to 12 K square L square. K and L denote the units of capital and labor employed in the production process. So we want to maximize this subject to the constraint that is 40 times K plus 5 times L should be equal to 800. Okay, this is our problem here, rather the question in simplified form. So graphically, what exactly is meant by this? If I draw the units of labor on the horizontal axis, units of capital on the vertical axis, and if I draw our production constraint, that is denoted by this line. Okay, so with the given production constraint, firm will try to produce at a point where the production constraint and the isocont are tangent to each other. That is, so optimal units of labor and capital will be at a point where the production constraint and isocont are tangent to each other. Let me draw the isocont here. Okay, let us say this is our isocont. So this is our isocont. So optimal combination of labor and capital, so let us denote by L star and K star, will be at a point where the production constraint and what we call the isocont are tangent to each other. Okay, so at this point where the slope of this constraint, production constraint, is equal to the slope of the isocont. Okay, so what exactly is meant by this? So let me write. The condition will be that at this point, what condition is being satisfied? At this point, our marginal rate of technical substitution between labor and capital, that marginal rate of technical substitution denotes the slope of the isocont, and it should be equal to the input price ratio, that is price of labor upon price of capital. Okay, can you find out what is price of capital and labor? Here we can see, since we have this constraint 40 times K plus 5 times L is equal to 800. So this 40 denotes our price of capital and this 5 denotes the price of labor. Okay, so this denotes the slope of this constraint. Okay, this what we call the budget constraint also in the utility maximization process, but here we have the production maximization process. So this denotes the slope of this line and this denotes the slope of the isocont. Now what is marginal rate of technical substitution? It is simply the ratio of the marginal product of labor upon marginal product of capital, and it should be equal to the input prices ratio, that is price of capital is 40 and price of labor is 5. Okay, now what is MPL? What is MPL? Marginal product of labor is simply the change in the output due to the change in the units of labor employed. Okay, mathematically it is the partial derivative of the production function with respect to L. Okay, so given this production function, its derivative partially with respect to L will be, so the exponent of L becomes coefficient. So first we have 12 times the exponent of L becomes coefficient, we have 2. K square will remain same because we are taking the partial with respect to L, but the exponent of L will be subtracted by 1 by power function rule. Okay, so 2 minus 1 is 1. So our dq upon dl comes out to be 2 20s are 24 K square L. This is our marginal product of labor. Similarly, the marginal product of capital is equal to the change in the output due to the change in the units of capital employed. Mathematically, it is simply the partial derivative of the production function with respect to capital. Okay, using the same logic here, by power function rule, the exponent of k becomes coefficient and exponent is subtracted by 1. So we have 12 times 2 raised power k, because 2 minus 1 is 1. L square will remain as it is. Okay, now using this condition, so MPL is 24 k square L divided by MPK is again 24. Okay, so this comes out to be 24 KL square. Okay, so we get 24 KL square should be equal to input price ratio. This is 40 upon 5, 40 upon 5. Okay, it implies here 24 gets cancelled, so 1L will get cancelled, 1K will get cancelled, so we will be left with K upon L is equal to 40 upon 5 is 5 1s are 5 8s are. Okay, or we can say K is equal to 8 times L. Okay, now what we do, we simply plug this equation, to say so, back into the budget constraint. Okay, in our production constraint, here we plug the value of, here we plug the value, okay, to find out the optimal combination of k. So we have 40 times the value of k is 8L plus 5 times L should be equal to 800. Let us solve it. 8 zeros are 0, 8 fours are 32. I guess I am doing it correctly. So 320L plus 5L is equal to 800. So this is 325L is equal to 800. Solving further. Okay, 325 upon 8. So L will be equal to 800 divided by 325. Okay, let us do the calculation here. Okay, let us get the specifics here. So we have 800 divided by 325. Okay, let me do. So both are divisible by 5. So we will get first 5 1s are 5. 6 7 8 I think 3 bana through 5 6 are 30, 5 0s are 0. Okay, here we get 5 6 are 30, zuhre 5 5s are 25. Again they are divisible by 5. So let us do it again. So we get here 5 3s are 15, 5 2s are 10. Here we get 5 1s are 5, 5 1s are 5. Okay, so am I doing it correctly or not? I am not sure. Okay, I am getting a fractional number here, 32 upon 11. Okay, so let me see if I have done it correctly or not. 12 2s are 24, so it is correct up to this. So we have 40 here. Okay, k is equal to 8L. 5 1s are 5 8s are 40. So k is equal to 8 times L. Then I plugged the value of k is equal to 8L here. So we get 40 into 8. 8 4s are 32, 330. Okay, 32 plus 5 is it becomes 325 upon 800. Okay, okay, let you check whether I have done it correctly or not. I am getting the value of L is equal to, rather L is equal to 32 upon 11. Okay, let me again check whether I have done the division correctly or not. So first I did 5 1s are 5, 6 7 8, 3 5 6 are 30. Okay, 5 0s are 0. Here I have done 5 6 are 30, 5 5s are 25. Okay, so I'm not sure whether I have done it correctly or not. So this is the units of capital there should be employed. That is equal to 32 upon 11. To find out the units of capital employed, we plug the value of L is equal to this stuff into this equation. So K will be equal to 8 times 32 upon 11. So okay, why I'm doing it here, why I'm confused, because no option is matching here. Okay, it means I have done rather the options are incorrect, or I have miscalculated the condition here. Okay, rather the question. Okay, so in any case the logic is pretty simple. What we do in case of maximization, we maximize the production function subject to the given production constraint. Okay, so we know that production will be maximized, or we get the optimal units of labor and capital at a point where the slope of the ISO count is equal to slope of this constraint, where M or T as marginal rate of technical substitution between labor and capital is equal to the input price ratio, price of labor upon price of capital. Okay, but I guess I have I have done a mistake here. I can see now. So we have price of labor here, and I have, so the whole thing is okay, my mistake here. So price of labor is in fact 5 and price of capital is 40. Okay, I have done opposite of that very stuff. It is actually 40 upon 5, it is actually 5 upon 40. Okay, so it is like this, 5 upon 40, so it will be equal to 1 upon 8. Okay, so here we will have 1 upon 8. That is why I was I'm just trying to save this. You can see one mistake here ruined in fact this question. So we have here 1 upon 8. Let me write it here, 1 upon 8. So we have k upon L. K upon L is equal to this stuff. So let me solve it again. So we have 8 times k is equal to L. So we plug the value of L is equal to 8k in this equation. Okay, so now it seems to be correct. So we have 40 times k plus 5 times the value of L is 8k. So 8k should be equal to 800. Okay, so this becomes 40k plus 8 5s are 40 again. 40k is equal to 800. So this is 80k is equal to 800, dividing both sides by 80. So now we can get the correct, because the problem was I have miscalculated here, because price of labor was 5 but price of capital was 40. Okay, here 0 0 gets cancelled, 8 1s are 8 10s are. So units of capital to be employed will be equal to 10. That means we get 10 here, and here let us find out the units of labor employed. Simply plug the value of, so here we got k is equal to 10. Plug the value of k is equal to 10 in this equation to find out the units of labor employed. So it will be equal to 8 times 10, which comes out to be 80. Okay, so the units of labor employed will be equal to 10, units of capital employed will be equal to 80. Okay, so the whole calculation got wrong, where I have miscalculated the slope. Slope was in fact 1 upon 8. I have written it 8. Okay, I hope I have rectified my mistake and you find out this video helpful. Thank you.